Hi everyone, I hope you're okay, and I hope that guys the videos we keep uploading are helping you out. This is video number one, guys, of which I'm about to do 11 videos whereby I'm tackling the past exam question papers with regards to momentum and impulse. So if guys this is the first video you come across, please note that guys there's already a playlist whereby I teach momentum from scratch, and another playlist whereby I'm answering these type of questions, the past exam questions. There will be 11 questions in total. So just stay tuned guys and wait for more videos. Before I even start guys, please guys do share this video to your peers. A thing or two that I mentioned here, I believe it will be helpful to them, whether elevating their knowledge, preparing for an upcoming test, or or preparing for the exam as well. So please don't forget to like the video as well if you're getting helped. Uh, do ask questions on the comment section if there are things you don't understand, and please help us to grow the channel by just subscribing. Okay, question one. A bullet of mass 10 grams moving at a velocity of 300 meters per second strikes a wooden block of mass 1.99 kilograms resting on a flat horizontal surface as shown in the diagram below. Um, the bullet becomes embedded in the block. Ignore the effects of air friction. Okay, before we start guys, we are told that we must ignore the effects of air friction. There's no applied force here, there's no tension, which simply means there are no non-conservative forces. If there are no non-conservative forces, we are dealing with a closed system, or rather an isolated system. Are we together? Before we even start guys, this question is a momentum question. Momentum is a vector. And the vector, we always know that it has magnitude and direction. So it's always important to choose a positive direction. Are you together? So every movement towards the right will be positive. Are you together? And before we start, we have two objects. They have object A, which is the bullet, and object B, which is the block. This will be quite handy whenever you calculate. Now let's answer the questions. First question: write down in words the principle of conservation of linear momentum. It simply states that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Okay, and then 4.2, we are being asked to calculate the speed of the block bullet system immediately after collision. So before collision, the bullets and the block were separated, but after collision, they became one system. Are you together? So we can simply say the sum of the momentas before is equal to the sum of the momentas after. This statement is true. Why is it true? Because we have an isolated system. Are we together? So we can simply say momentum of object A. Remember that momentum is mass times velocity. So momentum of object A initially plus momentum of object B initially. This is equals to, after collision they become one system. So we're just gonna add their masses, mass of A plus the mass of object B multiplied by a velocity. So all I have to do now guys is to just substitute now. Remember that guys, in physical science your mass should always be in kilograms. That means we must convert that 10 grams to be in kilograms, right? So we're going to divide it by 1,000. You'll simply get to 0.01 multiplied by the velocity. That's a positive 300 plus 1.99. The wooden block was resting guys before collision, so its velocity was 0 meters per second. Okay, and then we have 0.01 plus 1.99 multiplied by the velocity. we'll have 3 on the left hand side, we have 2 multiplied by Vf on the right hand side. So therefore the final velocity is 1.5 meters per second. Since it's positive, it means it's moving towards the right, né? But we were not asked to find the velocity. We were asked to find the speed. Remember that speed is just a scalar quantity. It only has a magnitude only. So the velocity, the speed of the block bullet system is just 1.5 meters per second. Okay. And then now we are told that the floor exerts a constant frictional force of 8 newtons, on the bullet block systems as it comes to rest. Calculate the distance that the bullet block system moves after collision. Okay, just after collision, guys, we will call maybe let's say the bullet will travel, the bullet block system will travel this distance over here. We can call the initial part the initial place P and the final place Q. The velocities of the bullet block system just before collision. Let me write in a different color. The velocity at point P, we know it's 1.5 meters per second, and the velocity at point Q, that's 0 meters per second. Why? Because the bullet block system will come to a stop. Are you together? There's only one force which is acting parallel to the surface, that's frictional force. Are you together? And frictional force is always opposing motion. So we can simply use the work energy theorem here. Because if you would draw a free body diagram of the bullet block system, yes, you'll have your normal force, and you'll have your weight, and then you'll have a frictional force. Are you together? There's no force there's no force that pushes the block to move towards the right, and hence it comes to a stop. So the only force which is acting horizontal is the frictional force, né? So we can simply use the work energy theorem, guys. Please, guys, don't be afraid. This question paper was extracted from a final examination. Obviously, towards your final examination, you would have learned the entire topics. This is work energy and power. It's the easiest. Don't worry about it, guys. So we'll simply say work net is just equal to the change in kinetic energy. This is work energy theorem, and it states that the work net done on an object is equal to the object's change in kinetic energy. But remember that, guys, work done by a force is equal to a force multiplied by the displacement cos of theta. Are you together? If I want to find the work done by applied force, that means I'm going to use force applied here. Are you together? If I want to find work done by gravity, that means I'm going to use the force of gravity there. So if I want to find frictional force, work done by friction, I'm going to use a frictional force there. Are we together? So same applies. I have work net. That means I must have work net over there. So this thing is simply equals to F net delta X cos theta. The change in kinetic energy, half mv squared final minus half mv squared initial. Okay, the only force which is present here is a frictional force. Its magnitude is 8 newtons. And then we want to find the distance traveled by the bullet block system, cos of 180 degrees. This cos over here is the cos, no, not cos rather, the angle theta is the space between the direction of motion and the force in question. Are you together? The bullet and block system is moving towards the right. However, frictional force is acting opposite. The angle in between here is just 180 degrees. Are we together? So this is equal to 1 over 2 multiplied by 2 and 0 squared. 1 over 2 multiplied by 2. What's the velocity? It's 1.5 squared. And then on the left hand side, we'll simply have negative 8 multiplied by delta x. And then we'll have 1.5 squared. We'll have 2.25, negative 2.25 on the right hand side, because this will be 0, and then negative half times 2 times 1.5 squared will give us a negative 2.25. If we divide both sides by 8, we'll simply get to delta x to be equals to 0.28 meters, which simply means that the block bullet system will just travel a distance of 0.28 meters. That's how, guys, we're supposed to tackle this question over here. And I hope that, guys, the video helped you out. Please, guys, don't forget to like, share to your peers, and help one another, and subscribe. Bye.